second video. And let's read this and look for some important things. First off, I don't care if it's a radar unit being scored to do speeds on a highway, but I do care that these speeds are normally distributed. That's very important. So is the fact that the mean is 90 and the standard deviation is 10. What's the probability that a car picked at random is traveling more than 100? So more than 100 means 100 or more miles per hour. It's a normal distribution, so that's second VARs, normal CDF, what we talked about before, normal meaning normal distribution. The lowest speed they want to talk about is 100 because it wants to be more than 100. So the lowest speed's 100. And whenever we want to get to the greatest value the calculator can compute when you're greater than something, it's always 10 to the 99th. Okay? The mean goes next, that's 90. The standard deviation goes last, that's 10. Punch the numbers into the calculator, it'll say 0.1587. On a side note, I drive very fast, and I can think of only 3 times in my life when I hit 100 miles per hour. So these guys are going really, really, really quick. And that doesn't mean you should drive fast. You should definitely not drive fast. Am I clear about that? Tickets, problems, deaths, it's not a good thing. My 3 cases were very, very specific cases. Once I got stuck behind a log truck in Canada, I had to get around the guy. Another time I was driving over the Tappan Zee Bridge, and it was the first time ever with my first own car, and it had a 454 engine in it, and Born to Run by Springsteen came on, so I had to hit it. The other time was on my way to Gaspé salmon fishing in Canada also. All right, so anyway, number 8. This is an indicator of a normal distribution, X tilde N for normal. This is the mean, 75.5. You have to recognize that the mean goes first in this notation, and the standard deviation goes second. So the mean is 75.5, the standard deviation is 4.7. What's the 90th percentile? When you try to do percentiles, this is so much easier than looking it up in the table. You have to use the inverse norm function. So all of this normal curve stuff can be found in second VARs. So you go to second VARs. Then you look up inverse norm. It's the third one down. What percentile do you want? I want the 90th percentile. As a decimal, that is 0.9. And then I put the mean, 75.5, and the standard deviation, 4.7. I just punch it into the calculator. Enter, enter, enter. It'll tell me 81.52. So that's the score at the 90th percentile. What's the 35th percentile? Well, let's do it again. Second VAR's inverse norm. But this time, instead of putting 0.9 for 90%, I put 0.35 for 35%. The mean is 75.5, and the standard deviation is 4.7. So it's always inverse norm, whatever the percentile you want, expressed as a percent. Expressed as a decimal. Always expressed as a decimal. Then mean, then standard deviation. Okay? Number 9. Personal computer is used for office work at home, research, communications, personal finances, etc. Suppose that the average number of hours used for a day is 2 hours per day, and assume that these times for entertainment are normally distributed. Ding, 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 ding. That's normal curve, and the standard deviation is half an hour. Half an hour is 0.5. So find the probability that a household's personal computer is used for entertainment between 1.8 and 2.75 hours per day. Okay, second VAR's normal CDF because it's normally distributed. Lower number, 1.8. Higher number, 2.75. Remember, it's always lower, higher. Mean, which is 2. And standard deviation, which is 0.5. Put the numbers in, crunch them out, you get 0.5886. Number 10. Find the population with a mean of, for a population with a mean of 75 and a standard deviation of 7. Find the z-score. Well, here's your z-score formula. The z-score is the x-score minus the mu for mean over standard deviation. It says here the standard deviation is 7, so 7 goes on the bottom. And it says an x-score is 73. So I do 73 minus 75, because 75 is the mean, over 7. I get negative 2/7. If they want a decimal, negative 0.28571. And there may be more decimal places, but it'll match your calculator. Or they may have you round off to the nearest hundredth, like negative 0.29. Whatever they do, it'll match the choices. Okay, number 11. For a population with a mean of 75 and a standard deviation of 7, find the x-score if the z-score is 1.4. So now you're going to put the 1.4 into the z-score area. I don't know the x-score, so I'm going to leave that as x, minus 75, because that's the mean, over 7. Multiplying both sides by 7, I get 98 equals x minus 75. Adding 75 to both sides, and I get 84.8. And that's my correct answer. Okay? Number 1 underneath. A researcher uses an anonymous survey to investigate the study habits of American college students based on the set of 56 surveys that were completed and returned. Based on the set of 6 surveys that were returned, the researcher finds these students spend an average of 4.1 hours a week. What is the 4.1 hours? It's a statistic because it's taken from a sample. There's more than 56 college students in the United States. So that was just 56 returned surveys. Statistics come from surveys. Remember, PPSS, population will give parameters, and samples will give statistics. Okay? Number 2, a researcher is interested in eating behavior of rats. Why? I do not know. And selects a group of 25 rats to be tested in a research study. The group of 25 rats is an example of, it's a sample. Because he has more than 25 rats, he's selecting a group, which implies that it's a group of the more or the greater population. So that is a sample. Okay? Next up, number 12. Find the mean, median, and mode for the scores of the following frequency table. The mode is always the most popular. So this means F is frequency. There's 1 8, there's 4 7s, 2 6s, 2 5s, 2 4s, 1 3. There's 4 7s, so that's your mode. 7 is your mode, and that's what it says down here. As far as the mean goes, I just do the x value times the frequency. 8 times 1 is 8, 7 times 4 is 28, 6 times 2 is 12. I mean, I could list 8, 7, 7, 7, 7, 6, 6, 5, 5, 4, 4, 3. But just by multiplying them, it's a quicker way to add them up. And if I do 69 divided by 12, which is what I get when I add them up, I get 5.75. So that's the mean. Total of them divided by how many there are. Okay. Some people might think there's only 6 scores here. There's 12 scores here. There's 1 of the 8s, there's 4 of the 7s, there's 2 of the 6s, and so on. There is a total of 12 scores, not 6 scores. Okay? How would it make sense if I divided by 6? Then my mean would be like 11.5. The highest score in the group is 8, so that would make no sense. The median is the one in the middle. There's 12 scores total, so 6.5 score, if you will, between the 6th and the 7th. And the 6th and the 7th scores are both in when x is equal to 6. So the median is 6. Okay? Last one for this particular page, the population mean annual salary for plumbers is $59,300. Now that's the mean average salary. A random sample of 49 plumbers is drawn from this population. What's the probability that the mean salary of the sample? So this is going to be a normal again, but it's going to be normal salary of the sample, which means that you need to divide by the square root of the sample size at the end. So the scratch work, lowest is 47,300 because you want to have samples greater than 47.3. So 47.3 is the lowest. 10 to the 99th is the highest. The mean is 49,300. And then for the SE here, we're going to get 5,500 divided by the square root of 49. Pump that into your calculator. You get 0.99454. That's all the room I got for the second video.